In this video, we will discuss some common misconceptions in mathematics. This slide, as well as the next 3 slides, give you an outline that show the topics that will be discussed. These statements are all incorrect, but they are statements that, as a private tutor, I have seen students make many times. The slide numbers are given so that you can skip to the topics that interest you. You will notice that the slide numbers are in the lower right-hand corners of the slides. And again, notice that all of these statements are wrong. These statements are also wrong, but they will be discussed in our second video on common errors in math. In this video, I will discuss the correct answers to these expressions as well as the reasons why the rules say what they do. And these statements are also wrong, and they will also be discussed in the second video on this topic. The first set of common fallacies that we will discuss concerns the order of operations. Before we can discuss these fallacies, we will review what the order of operations says. The order of operations is a set of rules that we use when we have more than one operation in a sentence. It says that we must start by simplifying everything in parentheses, and then after we've done that, we can move on to exponents, and then we can move on to multiplication and division in order from left to right. And then after we've done that, then we can move on to addition and subtraction in order from left to right. The mnemonic device, "Please excuse my dear Aunt Sally," is a phrase often used to help people remember this. For example, notice that both of the expressions you see here involve more than one operation. To work the one on the left correctly, we must start by multiplying 2 times 5. 2 times 5 is 10, and then we can add 7 plus 10 is 17. So the correct answer to this question is 17. To work the problem on the right, we must start with our exponents. Notice that 4 to the second power is equal to 16, and then 30 minus 16 is equal to 14. So the correct answer to this question is 14. When they see this problem, many people believe that the order of operations says that they must start with the multiplication. However, you should notice that the order of operations says that you should multiply and divide in order from left to right, like you read the words on a page. In this problem, the division comes first, and so we must start by dividing 20 by 5. 20 divided by 5 is equal to 4, and 4 times 2 is equal to 8, so the final answer to this question is 8. Many people also believe that you must always add before you subtract. However, addition and subtraction should also be done together in order from left to right. Since the subtraction comes first in this problem, we must begin by subtracting 18 minus 2. Since 18 minus 2 is equal to 16, and since 16 plus 6 is equal to 22, we can conclude that the final answer to this problem is 22. Now, let's look at another common misconception. Many people believe that the correct answer to both of these expressions is positive 81. However, in the expression on the left, only 3 is being raised to the 4th power. Depending on how you look at it, The negative sign should be dealt with in either the multiplication-division step or the addition-subtraction step. And of course, exponents should come before multiplication-division and addition-subtraction. So, since only the 3 is being raised to the 4th power in the problem on the left, the correct answer to this problem is negative 81. You can contrast this with the problem on the right. This example does tell you to multiply negative 3 by itself 4 times, and so the correct answer to this example is positive 81. If you're still having trouble with this, you can think about these two problems. They are saying exactly the same thing as the problem in green. You should notice that when you follow the order of operations to simplify them correctly, the final answer to both of them is negative 81. Before we look at our next popular misconception, let's review the distributive property. Normally, when we have an expression inside a set of parentheses, we must simplify the expression inside the parentheses before we can move on to the next step. However, the distributive property gives us a slight exception to this. When we have 2 or more terms that are being added or subtracted inside a set of parentheses, and we want to multiply something by the expression in the parentheses, we can multiply that something by each of the terms. In other words, we distribute the term outside the parentheses to each of the terms inside the parentheses. This allows us to simplify expressions like 2x plus 3x. Notice that we can use the distributive property to say that x times 2 plus 3 is equal to 2x plus 3x. Since 2 plus 3 is equal to 5, you should be able to see how you can easily simplify this and say that it must equal 5x. Similarly, we can say that 2xy plus 3xy is equal to 5xy. However, you should notice that you cannot use the same principle to simplify 2x plus 3y. If you would like another way to think about these problems, you can pretend that the x's represent apples, the xy's represent bananas, and the y's represent oranges. Therefore, the first problem asks you to put 2 apples together with 3 apples. Since this gives you 5 apples, you can see how the answer to this problem is 5x. The second problem would ask you to put 2 bananas together with 3 bananas, and you would get 5 bananas. The third problem would ask you to put 2 apples together with 3 oranges, and you can see how you cannot simplify this any further. When they see this problem, many people try to add 9 plus 2 and then distribute the 11 to the x and the 4. However, the order of operations tells us that we cannot do this. The order of operations tells us that we must multiply and divide before we add or subtract, and so we must begin by distributing the 2. Now we can combine like terms. Note that 9 minus 8 is equal to 1, and so we can write our final answer to this question as 1 plus 2x. We can also write it as 2x plus 1 because addition is commutative. When students look at this example, many of them try to start by distributing the 4 to the 2x and 3y. However, the distributive property talks about what happens when the terms inside the parentheses are being added or subtracted, and of course the terms in the parentheses here are being multiplied. This means that, in order to work this problem correctly, we must start by multiplying 2x times 3y. We do not have to worry about like terms here, because we worry about like terms when we add or subtract. Note that 2x times 3y is equal to 2 times x times 3 times y, which simplifies to 6xy. Now, we can use a similar thought process to say that 4 times 6xy is equal to 24xy. Our next common error talks about absolute values. Recall that absolute value symbols tell you to simplify anything inside of them and then make the answer positive. So, for this first example, we must begin by noting that negative 4 plus 1 is equal to negative 3. Then, since the absolute value of negative 3 is equal to positive 3, we can conclude that the final answer to this question is positive 3. For this next example, we must begin by noting that 9 minus 2 is equal to 7. Then, since the absolute value of 7 is equal to positive 7, the final answer to this question must be 7. In order to simplify the absolute value of x minus 2, you must first subtract x minus 2. However, since these are not like terms, we cannot do this. Therefore, we cannot simplify the absolute value of x minus 2 unless we know more information about what x equals. You might also notice that this problem is very similar to the last one. In fact, you should see that the problems are identical if you replace the x with 9. You should also notice that 9 plus 2 is equal to 11, and so, since we decided the final answer to the previous problem was 7 and not 11, you should be able to see that the absolute value of x minus 2 does not equal x plus 2. As I said earlier, a lot of students will tell me that 4y to the third is equal to 4y times 4y times 4y. However, you should realize that this problem is asking you to multiply 4 by y to the third, and the order of operations says we must worry about the exponent here before we do the multiplication. Therefore, only the y is being raised to the third power here. In this example, both the 4 and the y are being raised to the third power. So, when we put parentheses around the 4y, we find that this equals 64y to the third. As another example, only the b is being raised to the second power here, but the entire negative 5ab is being raised to the second power here. To simplify negative 5ab times negative 5ab, note that negative 5 times negative 5 is equal to 25. A times a is equal to a to the second, and b times b is equal to b to the second. As I said in the introduction, a lot of people tell me that they get x squared plus 36 when they square x plus 6. But you should notice that the order of operations tells us that we must add x plus 6 before we can deal with the exponent. This presents a problem, though, because we cannot combine them since they are not like terms. So, let's look at what this means. When we want to square something, that means we want to multiply it by itself. Now we can use a version of the distributive property. We can multiply the x from the first set of parentheses by each of the terms in the second set of parentheses, and then we can multiply the 6 from the first set of parentheses by each of the terms in the second set of parentheses. When you simplify this, you should find that you get x squared plus 12x plus 36 when you square x plus 6. Now let's look at another concept. As I said earlier, many students will tell me that this is equal to 3x plus 15 squared. However, you should notice that the order of operations tells us that we must take care of the exponent before we can multiply by 3. To work this problem correctly, we can use the concept that we discussed in the last slide to say that x plus 5 raised to the second power is equal to x to the second plus 10x plus 25, and then we can distribute the 3 to each of the terms. Next, let's look at a common misconception involving fractions. To reduce 15 over 24, we can divide both the top and bottom by 3. We can also reduce 3x over 3 by dividing both the top and the bottom by 3. Similarly, we can reduce 8x over 4 by dividing both the top and the bottom by 4. This problem here, though, is a little different. If you think about your rule for adding fractions, you ought to be able to see that the two expressions in purple are equal to each other. This should tell you that this expression is equal to 3x over 4 plus 2, and not 3x plus 2, as many students try to tell me. You should notice that this example is different from the examples in blue because there is an addition sign between the 3x and the 8, and there were no addition or subtraction signs in the examples in blue. You should also notice that there is an implied set of parentheses around the 3x plus 8, and so we must simplify 3x plus 8 before we can divide. These examples and the thought process behind them give rise to the following rule. You can only cancel something if it is multiplied by everything else on the top and the bottom. In this example here, there is an x plus 2 multiplied by everything else on both the top and bottom, and so we can cancel the x plus 2's. You might notice that when I canceled the x plus 2's, I left 1's in their places. This is because when we cancel the x plus 2's, we are dividing both the top and bottom by x plus 2. You should also notice that there is a 15 multiplied by everything else on top and a 5 multiplied by everything else on bottom, and so we can divide both of them by 5. You could also note that 15 is equal to 5 times 3, and then say that you wanted to cancel the 5's. This tells us that this expression simplifies as shown here, but you cannot cancel anything else. Notice that there is a 3 multiplied by everything else on top, but there is not a 3 multiplied by everything else on bottom. You cannot cancel the x's or the 1's for a similar reason. Now let's look at another example that illustrates this concept. In this problem, you should be able to see that there is an a minus 2b multiplied by everything else on both the top and the bottom, and so you can cancel those. You can also divide both the 7 and the 14 by 7, since those are multiplied by everything else on top and bottom. Lastly, you should note that a squared is equal to a times a, and a to the third is equal to a times a times a. And so you can cancel the 2 a's that are multiplied by everything else on top with 2 of the a's that are multiplied by everything else on bottom. This tells us that this expression simplifies to the fraction shown here. Now, let's look at a common misunderstanding about square roots. A square root symbol tells you to ask yourself what multiplied by itself equals this number or expression. This means that the square root of 81 is equal to 9, because 9 multiplied by itself is equal to 81. As another example, the square root of 16 over 25 is equal to 4 over 5, because 4 over 5 multiplied by itself is equal to 16 over 25. It's also true that if x is greater than or equal to 0, then the square root of 36x to the second is equal to 6x, because 6x times itself is equal to 36x to the second. I put the condition that x must be greater than or equal to 0 here because if x is a negative number, then 6x would also be a negative number. While it is true that 6x times 6x is equal to 36x to the second, even if x is a negative number, we generally want the positive answer when we use the square root symbol. For these examples, you can simply take the square root of each piece. However, you cannot do this if you are asked to simplify the square root of x squared plus 9. The difference, as you might be able to figure out, is that the previous problems all involved only multiplication and division. The order of operations says that we must add x squared plus 9 before we take the square root, and of course we cannot do that. You can also see that when you multiply x plus 3 by itself, you do not get x squared plus 9. If you have comments or questions about this video, please feel free to contact us using the Contact Us link on our website. Also, don't forget to watch our second video on misconceptions in math.